This video is about the new engineering. It is new because it is so different. For example, it does not use heat transfer coefficient or electrical resistance or material modulus, etc. The new engineering has several advantages over conventional engineering. For example, nonlinear problems are much simpler to solve because the variables are combined in conventional engineering, whereas the variables are separated in the new engineering. The following example problem demonstrates that the solution of nonlinear heat transfer problems is much simpler if heat transfer coefficients are not used, as in the new engineering. This table compares conventional engineering and the new engineering by using both of them to determine the heat flux between two fluids separated by a flat wall. The equations in the first row are the equations used to solve this type problem. The blue equations are the given information. Except for the bottom two rows, the equations on the left are identical to the equations on the right. They say exactly the same thing. The equations on the left say it with heat transfer coefficients. The equations on the right say it without heat transfer coefficients. The only difference between the two solutions is that heat transfer coefficients are used in the conventional engineering solution and are not used in the new engineering solution. The equations directly below the blue equations result from substituting the given information in the equations in the first row. Note that the equation that must be solved in conventional engineering contains three unknowns: U, delta T1, and delta T2. Since we have three unknowns and only one equation, it is necessary to find two more equations that apply to this problem. The three equations are then solved simultaneously to determine U, then U is multiplied by delta T total to determine heat flux Q. We are not going to complete the conventional solution, but note that only a heat transfer engineer is likely to be able to solve it, and it would take him considerably longer than a minute to solve it. The equation that must be solved in the new engineering contains only one unknown and can be solved in about a minute using Excel. Note that the new engineering solution is so simple that every engineer can understand everything about the solution and can solve the problem much faster than a heat transfer engineer can solve it using conventional engineering. In summary, this table demonstrates that heat transfer problems can be solved without using heat transfer coefficients. And it demonstrates that nonlinear heat transfer problems are much easier to solve if heat transfer coefficients are not used. And it demonstrates that it is much easier to learn heat transfer engineering if heat transfer coefficients are not used. Note that equation 1 states that H is Q over delta T. Equation 3 states that R is E over I. And equation 5 states that E is sigma over epsilon. Note that H combines Q and delta T, R combines E and I, and E combines sigma and epsilon. And recall that one of the first lessons in math is that nonlinear problems are much simpler to solve if the variables are not combined. Parameters such as Q over delta T, also known as H, E over I, also known as R, and sigma over epsilon, also known as E, make it impossible to solve nonlinear problems with the variables separated, greatly complicating the solution of nonlinear problems. In the new engineering, Parameters such as Q over delta T, E over I, and sigma over epsilon are not used. Consequently, nonlinear problems are solved with the variables separated, greatly simplifying solutions. Different things cannot be proportional. Trees cannot be proportional to rivers because they are different things. Tigers cannot be proportional to airplanes because they are different things. Different things cannot be proportional. For 2,000 years, parametric relationships have described how parameters are related. For example, Newton's second law in the Principia is acceleration is proportional to force. Hooke's law is stress is proportional to strain. Newton was wrong. Acceleration cannot be proportional to force because acceleration and force are different things, and different things cannot be proportional. And similarly for Hooke's law. Therefore, parametric relationships cannot rationally describe how parameters are related. Newton did not deduce that acceleration is proportional to force. He induced it from data that states the numerical value of acceleration is proportional to the numerical value of force. Therefore, in order to be rigorously correct, Newton's second law and Hooke's law should state the numerical value of acceleration is proportional to the numerical value of force. The numerical value of stress is proportional to the numerical value of strain. We must therefore conclude that parametric relationships can rationally describe only how the numerical values of parameters are related. In the new engineering, parametric relationships describe how the numerical values of parameters are related. Parameter symbols in equations represent numerical value, but not dimension. If an equation is quantitative, the dimension units that underlie parameter symbols must be specified in an accompanying nomenclature. These are some of the laws of conventional engineering in the form generally expressed in engineering textbooks. Recalling that H is Q over delta T, and R is E over I, and E is sigma over epsilon, we may rewrite the laws of conventional engineering in this more revealing form. Note that these laws are analogs of the equation y equals y over x times x, and H, R, and E are analogs of y over x. Also note that the equation y equals y over x times x says two things. It says that y equals y, and it says if you want to calculate y, first calculate y over x, then multiply by x. That is exactly the methodology we used in the conventional engineering solution of the example problem. We wanted to calculate the heat flux, so we calculated the ratio of heat flux to overall temperature difference, then we multiplied by the overall temperature difference. These so-called laws are mathematically undesirable because they make it impossible to solve nonlinear problems with the variables separated, greatly complicating solutions. The complication arises because if y is a nonlinear function of x, y over x is an additional variable, and it greatly complicates the solution of the problem. Recall that in the example problem, the equation to be solved in conventional engineering has three unknown variables, whereas the equation to be solved in the new engineering has only one unknown variable. These equations are laws in the new engineering because they are always obeyed. They are dimensionally homogeneous because the parameter symbols represent numerical value but not dimension. For example, the first equation says that the numerical value of temperature difference is a function of the numerical value of heat flux, and similarly for the other laws. These laws have no place in conventional engineering because parameter symbols represent numerical value and dimension, and consequently these equations are dimensionally inhomogeneous. Note that the mathematical analog of conventional laws is never used in pure mathematics, and that the mathematical analog of the new laws is often used in pure mathematics.
In the new engineering, all laws that are analogs of equation 1 in conventional engineering are replaced by analogs of equation 2.
All parameters that are analogs of y over x in conventional engineering are abandoned. In conventional engineering, nonlinear problems are often solved using analogs of y over x. In other words, with the variables combined, methodology that is never used in mathematics.
In the new engineering, analogs of y over x are never used. For example, q over delta t and E over I and sigma over epsilon are never used. In other words, H and R and E are never used. In the new engineering, parameter symbols and equations represent numerical value, but not dimension. If an equation is quantitative, the dimension units that underlie the symbols must be specified in an accompanying nomenclature. All parametric equations are inherently dimensionless and dimensionally homogeneous.
Parameters such as h, r, and e are not required for homogeneity and are abandoned.
The laws are analogs of y equals a function of x.
Q equals a function of delta t, and delta t equals a function of q. Replace q equals h delta t.
E equals a function of I, and I equals a function of E. Replace E equals IR. Sigma equals a function of epsilon, and epsilon equals a function of sigma. Replace sigma equals E epsilon.
The new engineering should replace conventional engineering because the new engineering laws are analogs of y equals a function of x, and they provide a much better foundation than laws that are analogs of y equals y over x times x. And because the analogs of y over x used in conventional engineering are mathematically undesirable and are abandoned. And because the number of variables in nonlinear problems is reduced, greatly simplifying solutions. And because it has fewer parameters than conventional engineering and therefore is much easier to learn. And because it is a clearer and more powerful way to think, because you always think in terms of individual parameters, such as stress and heat flux and electric current, instead of ratios of primary parameters, such as sigma over epsilon, also known as E, Q over delta T, also known as H, and E over I, also known as R.
And because problems are always solved with the variables separated, the simplest way to solve problems, whereas in conventional engineering, nonlinear problems are often solved with the variables combined in analogs of y over x.
The new engineering should replace conventional engineering.
In this appendix, we are going to discuss the history of dimensional homogeneity, and we're going to critically appraise the conventional view.
From 300 BC to 1800 AD, the science community globally agreed that dimensions cannot be multiplied or divided, with the single exception that a dimension may be divided by itself. For example, feet may be divided by feet, and seconds may be divided by seconds, but feet may not be divided by seconds. Rational parametric equations are dimensionless. The equation F equals ma is irrational because the dimension of m cannot be multiplied by the dimension of a.
Newton's second law of motion, presented in the Principia, is not F equals ma. It did not become F equals ma until 100 years after Newton died.
Newton's second law presented in the Principia is a change in motion is proportional to the motive force impressed and takes place along the straight line in which that force is impressed. In the conventional view of dimensional homogeneity, dimensions can be multiplied or divided. Dimensions cannot be added or subtracted, and the dimension of each term in an equation must be the same. Multiply 6 times 9 means add 9 6 times. Therefore, things that cannot be added cannot be multiplied. The conventional view is irrational because it is based on the irrational premise that dimensions cannot be added but can be multiplied. 16 divided by 8 is the number of eighths in 16. By analogy, feet divided by seconds is the number of seconds in feet. Since the number of seconds in feet has no meaning, feet cannot be divided by seconds. And the conclusion we reach is that the view that prevailed from 300 BC to 1800 AD is correct. Dimensions cannot be multiplied or divided, with the single exception that a dimension can be divided by itself.